In this video, we're going to go over periodic trends. So what are the common things that you are able to notice in a periodic table? So the first periodic trend that we want to go over is ionization energy. So when we are talking about ionization energy, we are referring to the energy that should be absorbed by an atom in a gaseous phase or an ion in a gaseous phase in order to lose an electron. So if you have got an atom, now this should be in the gaseous phase. If it absorbs if it absorbs energy, okay, it's going to be able to lose an electron. Now this electron which is lost is a valence electron. Therefore, ionization energy is the energy required by a gaseous atom, and the important word is gaseous. So it can be a gaseous atom or ion. Okay. So the energy is required because you are absorbing, the atom should absorb energy for it to remove an electron, not any other electron, but a valence electron, an electron in the outermost shell. So ionization energy is the energy that is required for a gaseous atom or ion to lose a valence electron. So if this is your atom and electrons here, this electron to be lost, you need this, it needs to gain energy. This atom needs to gain energy. Okay, you supply it with energy and then it will be able to go out. So that is ionization energy. So the energy required to remove the first electron is called the first ionization energy. Now this very atom which is here that ion can also lose another electron. So it becomes 2+ after losing another electron. So the energy involved here is called the second ionization energy. This one can as well lose another electron in the third ionization energy, and so forth and so on. Now if you look at your periodic table, ionization energy increases going like that. Let me just write it properly and we see the reasons as to why it is like that. So having our periodic table like that, the ionization energy is going to increase. Okay. And then going down, the ionization energy is going to reduce. So that is the trend in ionization energy. And what are the reasons as to why those things are seen like that? So going from left to right has to do with effective nuclear charge. So what is effective nuclear charge? So effective nuclear charge is the net positive charge experienced by valence electrons. So the positive charge which electrons in the outermost shell are experiencing is what we call the effective nuclear charge. Remember, an atom has got the nucleus which is positive because there are protons there, and then the electrons which are negative. So because these are of opposite charges, there is an attraction there. So those which are in group 1, elements in group 1, have got an effective nuclear charge of +1. Group 2, it is +2. Group 3 is +3. So this is just telling us the number of electrons in the outermost shell. And then group 7, they've got +7 effective nuclear charge. So this is the net positive charge experienced by valence electrons. So those atoms which are in group 7 Take for example fluorine and those others in group 7, chlorine. They've got a higher effective nuclear charge. In other words, those electrons which are in the outermost shell experience a much bigger attraction to the nucleus as compared to those which are in group 1. As you can see, those which are in group 1 experience an attraction to the nucleus about 7 times less than those which are in group 7. So those in group 7 are more attracted to the nucleus. So that is the effective nuclear charge. Because of the effective nuclear charge, it is very difficult for you to remove an electron from an atom which is in group 7. That is because atoms in group 7 are strongly held to the nucleus. I mean, electrons found in the atoms in group 7 are strongly held to the nucleus because the nucleus is exerting a greater positive charge on the electrons, and so they are highly attracted to the nucleus. Because of that high attraction, it will be very difficult for you to lose this electron. And so for you to lose that electron, you need to supply a lot of energy, and thus the increase in ionization energy. Now, going from top to bottom, what is happening is the atom is becoming bigger. Like those atoms in period 1, they've got 1 shell, period 2, 2 shells, period 3, 3 shells, period 4, they have 4 shells. Just like that. So atoms are becoming bigger and bigger. Now this has to do with the radius from the nucleus to where the electron is. So if you consider period 1, the distance is so small. Because the distance is so small, there is a greater attraction between the nucleus and also the electrons in the outermost shell. Because there's a greater attraction, it is very difficult for you to remove that electron. For you to remove it, then you need to supply a lot of energy. A lot of energy. But this one, the distance is far away from the nucleus, and so it is loosely held to the nucleus. So you just supply a little energy, the electron will be able to go out. So that explains why ionization energy reduces going down. Now, even if we have said so, there are some discontinuities as we are moving from from left to right in a periodic table. We have got some discontinuities such as between the beryllium, we know beryllium is there, and then we've got boron, we have got nitrogen and oxygen, we have got phosphorus and sulfur. There are discontinuities. These are in group 5. This is in group 6. And then beryllium is boron is in group 3. Beryllium is in group 2. So we expect the ionization energy to increase like that. Now if you get beryllium and boron, ionization energy doesn't increase going in that direction. Instead it goes in this way. If you get nitrogen and oxygen, instead of it increasing going forward, it increases in this way. The same trend is experienced also in phosphorus and sulfur. Instead of it increasing going forward, it increases in this way. But what are the reasons? So if you consider beryllium, the atomic number is 4. And then boron is 5. Electron configuration is 1s2, 2s2, and then in here it is 1s2, 2s2, 2p1. So this one, beryllium ends in an s orbital, while boron ends in a p. Now what you need to know is energy from s to p reduces. Okay. The energy is going to reduce from the s orbital to the p orbital. Now because of that reduction in energy, it's very simple for an electron to be moved away from the p orbital than in the s orbital because of that reduction in the energy. So that explains why energy instead increases in the opposite direction. That is because the beryllium ends in the s and then the boron ends in the p. Now if we consider between either phosphorus and sulfur or nitrogen and oxygen, those have got the same reason. If we take nitrogen and oxygen, This one has a proton number of 7, this one 8. So the electron configuration is 1s2, 2s2, and then 2p3. This one is 1s2, 2s2, and then 2p4. If we just get the last orbital, so for nitrogen, there are only 3 electrons. Okay, we have got the first one, second, and third. Now when it comes to oxygen, in the p orbital, there are 4 electrons. 1, 2, 3, the fourth one comes here. Now this experiences what we call the electron to electron repulsion. So that repulsion always wants electrons away from each other. Remember, electrons are both negative, and so they are giving a force to each other. There is a friction. They want to always have maximum distance away from each other, and so just a small supply of energy will make one electron to go, and then one electron is going to remain free. But here each of them is occupying a single orbital, and so they are very free. And so for you to remove one, you need a lot of energy. That is why energy increases. So the same energy can be, the same expression can be given for nitrogen or phosphorus. Okay. So that is ionization energy. The other trend we need to understand is electron affinity. So remember, ionization energy is the energy that is required. Now electron affinity is simply the direct opposite. So when we are talking about electron affinity, is the energy released by a gaseous atom or ion in order so when it releases this energy. Okay, so ionization energy is the energy in this case we are talking about electron affinity. Sorry, I'm going back to ionization energy. Electron affinity, I said, is the direct opposite of ionization energy. When we are talking about ionization energy, just remember, we are saying this atom is going to lose an electron. And so what we said is, for each to lose that electron, it needs to gain energy. Now when you're talking about electron affinity, affinity is attraction. So this atom wants to attract an electron. Now this atom is in the gaseous phase. It wants to attract an electron to become a gaseous ion. Okay, so like that. So now because this thing here, it was positive because it lost an electron. This one has gained an electron, so it is negative. So what is happening is, for this electron to be able to gain for this atom to be able to gain this electron, it needs to lose energy. Maybe we can give an explanation concerning an atom like that. If you've got an electron here, if you want this electron to drop to a lower energy level, it has to lose energy. That is what happens. Because immediately it gains energy, it is going to go to a higher energy level. So this atom is gaining an electron, so it is supposed to lose energy. So the first ionization energy, the first electron affinity, is the energy that is lost for one electron to be gained. Second electron affinity is for the second electron to be gained. So electron affinity is the energy change associated with the addition of an electron to a gaseous atom. So it is the direct opposite to ionization energy. Now what is the trend when we are talking about it in the periodic table? How does it change when you are going down or up the periodic table? So actually electron affinity increases from left to right. So it is increasing like that. And then when you are going so going from down to top, it also increases. So going from top to bottom, it does reduce. So the electron affinity reduces if you are going from top to bottom. So now because we are saying increase and this is energy released, so in other words, this increasing we are talking about is becoming more exothermic because energy is being released. So it needs to become more and more exothermic. A lot of energy is supposed to be released for an electron to be gained in an atom which is, say, in group 7. Okay. Now there are also some discontinuities which we can talk about here, such as, let's look at one discontinuity or two. So if we have, let's get some atoms in group 1. Let's get lithium. Group 2, let's get beryllium. Group 3, boron. And then we've got carbon, nitrogen, oxygen, phosphorus, and then group 7, which is neon. So now this one has to release about 60 kilojoules of energy. Now this one, the energy that it releases is less than 0. Okay. So in other words, here, this reaction, for an electron to be gained by beryllium, energy is supposed to be taken in. So the energy is endothermic. Okay. So the energy here is endothermic. The rest you can see they've got negative values. That is because it is exothermic. And then if you come here, about 27 kilojoules will be released. Here is about negative 122. If you come here, it is also endothermic. Energy is supposed to be taken in. And then here energy will be released. Again here a lot of energy has to be released. Now here also energy is endothermic. Now why this discontinuity? Of course we know that energy is supposed, a lot of energy is supposed to be released going in that direction, but as we can see there are some discontinuities. So let's talk about beryllium. Beryllium ends in 1s2, 2s2. So both the orbitals have been filled up completely. So if you want to gain an electron when it comes to beryllium, you want to fill the 2p orbital. And if we draw these orbitals, this is the 1s, this is the 2s, and then we've got the 2p. So these two are already filled up. So gaining an electron means we want to fill that one. Now because we are filling an higher orbital, instead of losing energy, we have to gain energy for us to fill that orbital, and so that is why the energy is endothermic. We are adding an electron to a higher energy level. Okay. Now if you talk about fluorine, which has got a lot, which releases a lot of energy, why is it like that? So fluorine has got a greater nuclear charge because it has got a positive 7 nuclear charge. So valence electrons are strongly held to the nucleus. Okay. And then there is a space in the orbital, in an orbital, where an electron can be added. If we talk about fluorine, fluorine has got a proton number of 9. So the electron, if we draw the orbital diagram, the first one is there, the second one is there, and then we are going to have the 2p like that. So this is the 1s, 2s, and then 2p. So these two are completely filled up, and then it has got 9. So we are filled up 4, 5, 6, 7, 8. Okay. So we have got these orbitals which can be able to gain some electrons. And so these orbitals can gain electrons and a lot of energy will be released. That is why fluorine has got a higher electron affinity, because of those free orbitals which can gain such energy. Okay, I mean those free orbitals which can gain electrons, and at the same time there's greater affinity. In other words, because it has got a positive 7 affinity effective nuclear charge, an electron which is coming will be more attracted, and that more attraction will bring it in so quickly and a lot of energy will be released. Now if you talk about group 8 elements such as neon, argon, these have got filled up valence shells. They don't need any energy. I mean they don't need any more electron because all their orbitals have been filled up. And so that is saying for you to put an electron into an argon or neon or just these noble gases, you need to give them energy because they have already filled up orbitals. So it means you need to fill another orbital which has nothing, and thus the energy is endothermic. Those are the discontinuities which we can talk about when it comes to electron affinity. Another periodic trend that we can understand is electronegativity. Now, electronegativity is the ability of an atom to attract a pair of shared electrons. So, ability of an atom to attract a pair of shared electrons. So this happens when an atom wants to form a compound or a molecule. So that has to do with electronegativity. So assuming we have got nitrogen, let's say hydrogen and oxygen reacting. Hydrogen and oxygen. So when these two react, such as in water, they are going to form these two bonds. Now, because oxygen is more electronegative, these electrons which are shared in these bonds will be found more close to the oxygen than they will be found to the hydrogen. That doesn't mean oxygen has gained them and hydrogen has lost them. It's just that it has got a greater pull. It has got a higher affinity. Okay, there's a greater affinity with just from talking about electron affinity. So there's a greater electron affinity in oxygen, and because of that it pulls electrons towards itself. So electronegativity increases up the group. So if you are talking about the periodic table, so electronegativity is going to increase as you are going like that, just like we talked about electron affinity, and it also increases as you go like that. So the atom with the greatest electronegativity is fluorine. So as you go towards fluorine, electronegativity increases from any direction. Electronegativity is increasing. Okay. So that is about electronegativity. Maybe the other trend we can understand is ionic and atomic radius. Let's first start with atomic radius. So atomic radius is the radius or the distance from the nucleus to the outermost shell. So if you check in your periodic table, what is the trend for atomic and ionic radius? So atomic radius increases as you go to the right. So when you are going like this, we are saying atomic radius is supposed to increase. Is that true? Okay, we're going to come to discuss that one. So when you are going down, this one, atomic radius is increasing. Okay. So what we need to understand is atoms with a greater effective nuclear charge have a greater pull towards the nucleus, hence they shrink. So when you are going towards the right, atomic radius is supposed to decrease. Now let's find out why. So going down, the atoms are we are adding more shells. So the shells are increasing. As you can see, the distance from the outermost shell to the nucleus is increasing. Because of that, that is why the increase has been recorded in atomic radius. Now as you go from left to right of the periodic table, effective nuclear charge increases. And we talked about effective nuclear charge. For those in group 1, they've got an effective nuclear charge of 1, positive 1. Here it is positive 2, positive 3, positive 4, positive 5, positive 6, positive 7. So these, which are in group 7, have got a greater pool of electrons to themselves. Because electrons have been pulled more strongly, those electrons which are here have been pulled more strongly to the nucleus, the atom is going to shrink. It's becoming much smaller. And so that's why the decrease is recorded as you are going from left to right. That is because of the effective nuclear charge. So that is the trend in atomic radius. Now what of in ionic radius? What of if you are talking about ions instead of atoms? Okay. So, oh sorry, I'm writing ionic, supposed to be atomic radius. I mean ionic radius, I was writing atomic. Okay. Now ionic radius, we are simply talking of an ion. So let's talk for example about nitrogen and nitrogen minus. Okay. Of course we know that nitrogen can gain electron for it to be stable. This one needs the 3 more electrons to be stable, so it forms that ion with a negative charge. Okay, so what happens is cations, those which are positively charged, are smaller than their neutral atoms, while anions, these which are negatively charged, are bigger than neutral atoms. And how is that? Let's consider the reason. If we talk about nitrogen, how many protons does it have? So nitrogen has got 7 protons because it has got an atomic number of 7. Even electrons are going to be 7. And then even when it forms an ion, the protons don't change, but the electrons have changed. Why? Because it has gained more electrons. So it has gained 3 more, so they've become 10. Now as you can see here, the electrons and the protons are cancelling out. Now when it comes to here, the electrons are more than the protons. So it means this atom, so if we draw the electron, we draw the atom the way it is going to be, it's going to have 8 electrons in this outermost shell. And then the 2 are inside. So these 6 together with the 2 which are inside, oh, this one has gained 3, sorry, this one has gained 3. Okay, so the 5 valence electrons together with those which are inside are going to cancel with the proton number. In other words, with the protons which are in that shell. Remember, protons and electrons cancel each other. So 3 more electrons have remained. So these 3 more which have remained, there will be a repulsion between them. That repulsion makes the atom much bigger. Okay, so these anions are bigger than the neutral atoms because of the gain in electrons which has happened. Now if you are talking of cations or cations, those which have lost electrons, take for example sodium and sodium plus. So sodium has got a proton number of 11, so there are 11 protons and also 11 electrons. But here the protons are 11, it has lost 1, so the electrons are 10. So you can see that the protons which are attracting the electrons are more. So all these electrons will be attracted to the protons, and there is actually 1 proton which has remained. 1 positive which has remained is not attracting anything. So there's a greater attraction, and so the atom becomes okay, becomes much smaller. The ion is going to become much smaller than the actual atom. Why has it become much smaller? Because the pull is much greater. Remember, the pull is between the protons and the electrons. So that is why cations or cations are smaller than their actual atoms. So you can actually even compare different substances, different ions of different substances, such as you can talk of oxygen 2 minus and nitrogen 3 minus. Which one is bigger than the other? So if you consider oxygen, what's the proton number? So oxygen has a proton number of 8, So if it gains electrons, it has become now 10 electrons. This one has got a proton number of what? 7. So if it gained electrons, they are now 10. Okay, because it had gained 3 more electrons, as we can see above there. Now, the electrons are higher in nitrogen than the protons. So because the electrons are higher, it will be very difficult for these protons to pull strongly these electrons. So this will be much bigger. But when it comes to here, we have got 10 electrons and 8 protons. At least the protons are 8, it's just 2 less than the electrons. So they will be at least able to give an attraction to the electrons. And so the atom, in comparison to nitrogen ion, the oxygen ion, will be much smaller. So that is how you can compare those which have got different ions of different atoms. So the electrons can be the same, but consider the protons. Alright, thank you so much for watching this video. Have a blessed day.